we discuss in the previous session regarding the different strategies of doing a testing, right? Doing a software testing. The last strategy that we shown on our classes, previous classes, were top-down integration, right? Now, what does that mean? Simply, we get to know when we do the top-down integration testing, especially if I talk about the aspects of testing. So you'll be getting to know that while doing the top down integration, what you'll be saying, that basically what is top down integration. So top down is integration, as the figure shows, let's say for an example, this is layer 1. So the layer 1 plus 2 and the all the layer, it means this is the layer 1 plus 2 and all the layer. So this is how the testing approach means, this is how a type of a testing strategy that a tester follow. So this is known as what? Top down strategy, integration strategy, whatever you call it, right? So we learn about top down testing strategy, top down integration that we are talking about, right? So first we are talking about the layer 1, then layer 1, it means the previous layer and the new layer. So previous module with the new module. And A, B, C, D, E, F, G, H. This is how. Now next is Big Bang strategy or Big Bang testing strategy. What does that mean? Well, that means, let's say for an example, we do have a different modules which start with A, B, C, D, E, F, G, H as it is. Okay. So each of the modules are connected with the whole module. It means, say for an example, that it is convenient for a small project. Disadvantage, no need of drivers. So if you saw earlier in the previous lesson, we talked about it. So here we are requiring something which is known as stub for applying this testing strategy, which was top down testing strategy, and the upper one also bottom up integration, right? But in the Big Bang, we don't need any stubs or driver in order to test with the approach of top down integration and Big Bang strategy. Okay, so basically what we are doing, so no need of driver and stubs. Integration testing is only possible when all modules are ready. Of course, as the figure shows, guys, A, B, C, D, E, F, G, H. Okay, now if any of the module is incomplete or is not ready, then definitely the software is not going to be tested using which strategy? This one, Big Bang strategy or Big Bang integration. It means every integration should be connected and complete along with the main, right? So basically it says that integration testing is only possible when all modules are ready. Without that, it's not possible. Ease in missing interface faults. It means interface faults. Why it says that ease in missing interface faults? Because, say for an example, what I'm doing here, testing A, the first I design the module A, module B, module C, module D, and module E. So what happened is just, say for an example, we are going to do the integration testing at the end when the entire software is developed, and we are going to test using Big Bang method or Big Bang strategy at the last, right? So what will be the possibility that if, say for an example, at test F, this F module is having any issues, okay, or anything that is missing. Now it can be in terms of code, it can be in terms of test cases. So what is happening here is that we are unable to perform, we are unable to test a single module. Instead, we have to wait for the entire module to be finished, then only it can be tested. So what is happening is there, if say for an example, if any of the modules are having any issues, then it is going to be rectified or it is going to be fixed at the end only. So say for an example, I have built test A, okay, module A, module B, module C, correct? Now I got to know after completing the module H, okay, I get to know that there is some issues in module C or test C. So what gonna happen, guys, that from test C, whatever modules I have integrated, I have to make changes to all of the modules. So this is why it is says there is ease of missing the interface in each modules. It means each module can, if there is any issues, if there is something which is missing, if there is something which is not integrated in the modules, then it is going to be an issue at the end, because with the Big Bang strategy or Big Bang theory, we are going to test it at the very last. Okay, fault localization difficulty, it means that we are unable to come out with any fault the particular product or software or unit has while using or while testing with big bang strategy. Why so? Because guys, whenever we test a single module, here we are unable to perform any test cases, not even a single test cases on any modules. So at the end, when we are going to test the entire software, then we have to do it individually, right? We have to do it individually, and then that particular will take a lot of it will consume a lot of time, as well as there's a possibility that the localization fault, it means, say for an example, I'm building the login module. However, after completing within the login module, there can be many functions which can be registration, OTP, security key, right, as we discussed in the previous example. But what happened is that, say for an example, that if there is too many issues in the login module only, then the localization fault, it means I'm unable to perform any test within one module. Okay, so if any of the, I would say, that module is not working or sub module is not working, then still it will only be possible to know once the entire testing has been done, entire software is developed, then only the testing can be done using big bang strategy. So that's, it says that there is a localization fault. It means where we are unable to localize those defects and those errors while developing until the entire software is developed. Okay, critical path